And lastly, we're going to move on to group transaction comprehension. And we're going to have one transaction passed in, and then two transactions not passed in as arguments. And these I'm going to show you now. So let's say payment transaction and G transaction, we need to import to access properties of a group transaction. So payment transaction is group transaction dot payment transaction. And this is going to be passed in directly into this method call. And then we're going to have two other transactions, and we'll call this first transaction. And we'll have another two, so second transaction is going to be a generic transaction type of a group. And this will be, we'll have this be 1, so index 1. And then third transaction, G transaction, index 2. So what's going to happen is, and I'll start working on the method, and I'll comment this out. Instead of using a hashtag on each line, I'll just use 3 single apostrophes. So call ABI method, and this is going to be called group transaction comprehension. And then we're going to have an argument called first transaction. And this is going to be a payment transaction, which we'll create now. And so payment transaction, the sender will be our address, SP will be params, receiver will just be ourselves. Amounts, let's just send 1000 microalgo, and that's perfect. And then we just need a wrapped payment transaction, which is a transaction with signer instance with the payment transaction passed in, as well as our signer. And so we're going to pass in this wrapped payment transaction. And then afterwards, we're going to manually add transactions to our atomic transaction composer. So this will be the second and third transaction. So they won't be passed in directly. They'll just be included in the group. So let's create a asset transfer. Asset transfer transaction, sender is equal to address, SP is equal to params, receiver can be ourselves, amounts can be 1, and index, I believe we have it defined already, asset ID. So index equals asset ID. And that's all we need there. And we're going to wrap this asset transfer. So just create another transaction with signer instance, pass in the asset transfer and signer. And this is the transaction we'll be adding into our atomic transaction composer, the wrapped asset transfer. And then we're going to pass in another payment. So we'll just copy this payment that we just did and place it right before the last add transaction function. And we'll just have this one be for 2000 so we don't get a duplicate transaction error. And we'll pass in the wrapped payment transaction here. So now that we have a group with 3 outer transactions in addition to the application call, we can now access properties of the first transaction, which we're stating that this will be a payment transaction. So by default, first transaction will have attributes that you would typically see with a payment transaction, so amounts. as opposed to an asset transfer where you would see something like asset amounts. And then also you have receiver, where as opposed to an asset transfer transaction, you would have asset receiver. And what we're going to do is we're going to return a tuple with 3 uint64s. And these are going to be the amounts of each transaction. And you'll see that for second transaction and also for third transaction, we're just looking at second transaction right now, you have both amounts and asset amount. So the transaction generic type has access to all potential attributes, even app args, as if it was an application call. So what we can do here is set a variable called second transaction amount. And the way we can define this is if second transaction dot type is equal to, and we can grab the transaction type class here. If second transaction dot type is equal to transaction type dot payments, then we know that the second transaction will have a property called amounts. And similarly, if second transaction dot type is equal to transaction type dot asset transfer, the second transaction amount is going to be equal to second transaction dot asset amount. And we can copy and paste this for the third transaction. And we'll just Control D on all of this. And now we can return the second transaction amount and the third transaction amount. And this looks good. And we can also we can assert, add an assert up here, that first transaction dot amount is equal to, let's say, 1000 microalgo or 0.001 algo, which we have set already up here. And we can set that if it's a payment, assert that the second transaction type, or let's assert that the second transaction amount is equal to 1000 or 2000. Since we don't want a duplicate, we set this one to 2000. And if it's a asset transfer transaction, assert that second transaction amount is equal to, let's say, 1. And we can do that for the third transaction as well. And just change this to third transaction amount. And this has to be after we define the amount. And let's just type this out here. Assert third transaction amount is equal to 1. And we'll compile this. And launch. And make sure you change the approval clear TO file names to match your transaction contract. Go to our .env and replace the app ID. And let's go to our interact with contract. And so we're going to have a payment transaction of 1,000, which will pass the first assert statement. And the first transaction is included as an argument in the compose call. The second transaction and third transaction are not part of the arguments here, but they are included in the entire group. So for our first assert, we have if it's a payment transaction, make sure that it's for 2,000 microalgo. And here we have our first transaction as an asset transfer transaction. And the amount is 1. So it will not hit this since the second transaction is an asset transfer. So this if statement won't be triggered, but this one will be because it's an asset transfer. It'll get the amount and assert that it's 1, which we have set up. And then for the third transaction, it's going to check if it's a payment, which it is. And it's going to assert that the payment amount is 2,000, which it is. And then otherwise, if it was an asset transfer, it would make sure it's 1. And then we have the return statement for the amounts of the first, second, and third transaction. So let's try running this. And for our return values, I think this is fine. Yeah, this is good. Or actually, let's see if we get the return values. I believe the first transaction should not have. I to B arg0 wanted UN64 but got bytes. And this is because we need to keep track of the indexes for each transaction. So we have the payment transaction, which occurs first, the application call, then we have our second transaction, and then we have our third transaction. So 0, 1, 2, 3. So this should be 2, and this should be 3. And we'll recompile and relaunch. Adjust our .env. And basically what happened is when we called this function, and you'll see here, if I scroll up, it says, warning, second transaction amount potentially used before assignment. And then the error we got was wanted uint64, but got empty byte. So second transaction, for example, was an application call. So we had this originally set to 1. So when it went into the second transaction, which was an application call, this didn't trigger, and this didn't trigger, because an application call is neither a payment or asset transfer. So second transaction amount becomes none. So we have to be careful when we count the transaction indexes. So the arguments you pass in to an application call will always occur, if there are transactions, they will always occur before the application call. So if I have 3 transactions here, I'll have transaction 0, transaction 1, transaction 2, and then transaction 3 is the application call. And then the order in which you add transactions to the group will be in addition to this last placement. So that'll be 4 and then 5. So in this situation, we have 2 and 3, since we have one transaction here, and the application call. So 0, 1, 2, 3. And if we interact again, let me just switch over the, yeah, I already did that. We run this again, you'll see it's executing. And we get back 1000, 1, 2000. And then if I switch the order in which I add these transactions, so let's say I add the asset transfer after the payment transaction, and I execute this again, you'll see the 2000 and the 1 have switched places, so it'll be 1000, 2001. And this is a kind of flexible implementation, but typically you also wouldn't use fixed positions like this if you can foresee that your application will ever be used by others. You want to use relative indexes. So I want the second transaction to always be the one after the application call. So what I can do is get the transaction index, wherever this is, group index, plus 1. And then I want the third transaction to be the transaction.groupIndex plus 2. So this way, if you ever had someone who, say, wanted to call inner transaction 2, and then afterwards call group transaction comprehension, which we can even try now, they can do that. And even though we're adding transactions beforehand, it won't disrupt the flow of this, because now we don't have hard-coded indexes, we have relative indexes to the actual application call. And we'll even compile this now. And this is best practice. Wherever you can, use relative indicing for transactions. And let's launch this. And we'll put it to the test with, we'll have to fund the contract for those transaction fees. Let me just quickly grab this. And in our interact with contract, put in my new .env for the app ID. And our interact with contract, we're going to uncomment this second app and compose call for inner transaction 2. And we should see that it's successfully executing. And our ABI results, we're only accessing the first ABI result. So what we should do is state here, all ABI results is equal to results.ABI results I.return value for I in range of length results.ABI results. And printing it this time, we can do the same thing here. All transaction IDs is equal to results.ABI results I transaction ID for I in range length results.ABI results. And that should be fine, actually. And then we'll print all transaction IDs and all ABI results instead. And we won't need this here. That way we can see all ABI results because we're getting We were only getting the first ABI result, but now we have two. Oh boy. We're already opted in. Let's see here. Let's generate a new account. Or no, it's the application. So let's launch a new master contract or transaction comp. Because that's why I mentioned earlier, once you're opted in, you can't call an opt-in only ABI method a second time. And we're going to need to fund this again. I replace this, good. And let's print this results here. And we should see around like 4 or 5 transaction IDs. Oh, only 2. Okay, so the 2 application calls. And then we get 1, which was the result of this right here, which returns 1. And then we get the 1000, 2000, and 1, which are the amounts of first transaction, second transaction, and third transaction. But don't forget this. If you're going to get into smart contract development, always use relative indexing. And I think that wraps it up for group transactions. And we're going to get into some real advanced stuff. I have a marketplace contract we're going to be writing, as well as there's a Pokédex / Pokemon manager we're also going to write. And we're going to go over boxes, structs, and ARC69s, ARC19s. There's more coming. So this is a good start for you. The transaction comprehension, group transaction comprehension, and inter-transaction comprehension. All right, thanks.